First, if you write equation of plane in normal form, I am writing both the form scalar and vector form. Three-dimensional space. A plane is always characterized by a normal drawn to it. So normal form plays important role here. Plane may lie anywhere. It may be like this. It may lie anywhere. I am taking an arbitrary position of the plane here whose perpendicular distance from origin is equal to d, and unit normal drawn to the plane is along n cap. To find the equation of such a plane, like any other object in 2D or 3D, we will take a variable point on it. The variable point be R. This PR is this point actually. So if the point P lies on the plane and this is the perpendicular drawn, OM is the perpendicular, then OP vector is equal to R, and OM vector we can write this manner. OM vector is D into n cap. Now what is MP vector? MP vector is OP minus OM. So R minus D into n cap. Put OM perpendicular to PM. This will give us PM or MP, whatever you say. But as you have calculated MP, keep it in terms of MP. OM is perpendicular to MP. So their dot product will be equal to 0. This will give us R minus D into n cap dot so D 0 by D will give you 0 only. R dot n cap minus D n cap dot n cap equal to 0. So this is the equation of plane in normal form. By using vector, plane in normal form we got like this. Scalarly we can get, this can be shown by taking R equal to xi plus yj plus zk, and n vector along li plus mj plus nk, we can write lx plus my. This n is different from that. Nz is equal to, you can write p or equal to d. I am writing d here because same symbol will be using. And this LMN stands for direction ratios. LMN stands for drs of the normal drawn to the plane. Okay. So this is just a formula which is shown in vector form as well as in scalar form. Now to write the general equation, we can start from here only. We can write that L, if you take, suppose drs of normal be direction ratios of normal be A, B, C. Then L can be taken as A by root over sigma square C by root over sigma square. By putting it there and manipulating, the general equation of plane can be taken this way. Ax plus by plus cz is equal to D. We don't take D, we just change it here, P. Okay. So this is the equation of plane in general form. Now this can be written as x by P by A, y by P by B, z by P by C equal to 1. This plane, if you have expressed the plane in this form, then it is called intercept form. And normal form how to get? From here you got this one. But can I get normal form back? Yes, if I divide both sides by root over a square plus b square plus c square, c by root over a square plus b square plus c square z. I am dividing both sides by root over a square plus b square plus c square. This we can take as lx plus my plus nz is equal to d. Okay. So the scalar form and normal form, they are the general equation and normal equation, plane in normal form, they are interchangeable. From one form to another form we can easily express. And by now we'll remember the intercept form is this. What P by A stands for? If you have expressed in intercept form, that P by A stands for length of intercept made on x-axis. A equal to P by A, this we can refer as x-intercept. B equal to P by B, this is y-intercept. Similarly, big C is equal to P by small c, this is the z-intercept. Okay. Now, in some book you will find that the equation of plane written this manner also. This L is taken as cos alpha x, cos beta y, cos gamma z is equal to d or p, whatever they are writing. That d will be perpendicular distance from origin. Okay. Let us work on it first. Step by step, let us proceed. I am starting new manner today, that by using different technique today. So let us write the equation of, let the equation of plane be 3x plus 4y plus 5z is equal to 20. Okay. The question given here, express this in, express number 1 in normal form, number 2 in intercept form, and number 3 its perpendicular distance from origin. Once you express in normal form, then this d on right side stands for length of perpendicular drawn from origin to the plane. This we know. So first we'll try to express in normal form. Dividing by 3 square, 4 square, 5 square, 5 root 2. This changes to 3 by 5 root 2 x, 5 by 5 root 2 z equal to 20 by 5 root 2. So this is of normal, or what? 3 by 5 root 2 4. This is the normal form. And what is the distance from origin? distance from 0, 0, 0 equal to this term 20 by 5 root 2, 4 by root 2. This is understood. Distance from origin is 2 root 2. Perpendicular distance from origin is known now. But we haven't done number 1 is done, number 3 is also done, but we haven't done number 2. Number 2 is very easy, like straight line. Ax plus by equal to c was given, you divided both sides by c and you got the intercept form. The same manner we will be getting here. For intercept form, divide both sides by, we have 3x plus 4y plus 5z by 20 equal to 1. 20 by 3, y by 5, z by 4 equal to 1. 20 by 3 is x-intercept, 5 is y-intercept, and 4 is z-intercept. So the plane, if you try to draw here, it will be of this form. It will look like this. We are using this, we are seeing it from outside, and this plane we have drawn in two-dimensional coordinate system. It will look like that. This point is going to be 20 by 3, 0, 0. This is 0, 5, 0. And this one is 0, 0, 4. Okay. So this is on the plane in normal form, plane in intercept form. Let us know other forms also. 1 point form. This is equation of plane passing through a given point, and normal to the plane is given. Plane is situated anywhere, I told you. In this space. We are not expressing in that form where perpendicular from origin is involved, but automatically it will come once you express the resulting equation you will get in normal form. Any equation you can express always in terms of normal form. Here, the given thing is the normal. This is not unit normal, just normal and a point on the plane. A point on the plane is given as A, and normal to is along N to find the equation of the plane. You will be taking an arbitrary point always, because a variable quantity always there, that is the point on the plane which has infinitely many values. Once you join these two and produce it, they become perpendicular. It means AP dot n equal to 0. AP means position vector of P minus position vector of A. This is the equation of plane which passes through a point and normal to it is given. For example, equation of plane through A 1, 2, 3 and the normal is 2i minus 3j plus 7k. How to write? Direct formula application. The answer going to be that r minus a dot n, sorry, this will be I plus 2j plus 3k. Because the point has vector representation like this, this dot 2i minus 3j plus 7k equal to 0. Okay. So this is the vector form. This is enough if you write this manner. But if you say that now I want to express in scalar form, then you can take this one as r as xi, yj, zk dot 2i minus 3j plus 7k equal to 0, x minus 1 I cap, y minus 2 j cap, z minus 3 k cap dot this thing so this is going to be 2 into x minus 1 plus 7 into z minus 3 equal to 0. In fact, this you can get in the beginning only, because the form we have derived here, this is called vector form. Scalar form will be what way? That point be x1, y1, z1. x1, y1, z1. Then we can write the equation of plane in this form: a into x minus x1 plus b into y minus y1 plus c into z minus z1 0. Just put the value a here, and normally you take along ai plus bj plus ck, then you will get this equation. So this is one point formula. Like in this case, directly you can write. For some students, the scalar form looks easier because they will write simply that 2 into x minus 1 in one step only, minus 3 into y minus 2 plus 7 into z minus 3 equal to 0. Okay. You also can do, but vector form has several other advantages. So we learn vector form also properly. This is the basic plane equations which you always have to keep in your mind, that plane can be written in normal form, both scalar and vector. Plane can be written in terms of a point in it. Plane can have expression in intercept form. It can be expressed in normal form also. And now we are going to do